My name is Brad Urani. This is a talk about object-relational mappers. And object-relational map, or ORM, right, stands for object-relational mapper. It's the data access part of a web framework. So we're talking about web frameworks here. ORM, so ActiveRecord is the ORM from Ruby on Rails, and Ecto is the ORM from Phoenix, which is a framework for Elixir. What an ORM is, object-relational mapper, right? It's the part that converts the code in whatever programming language you're writing in into the SQL queries. So almost every website, right, has some sort of database component, and usually you're not writing raw SQL. So these different languages have different solutions for this, and I'm going to do a little compare and contrast here. Has anyone here programmed in Ruby on Rails? Okay, cool, great. So I work at Procore, where we have one of the oldest, largest Rails apps in the world. It's 12 years old now. The database has 400 or 500 tables in it, and it's got 30 people working on it every day. And what we're talking about, it's so funny. It's interesting thing happens when you have like 30 people working on the same application, is that you find that these frameworks, they all have different sort of, they also have sort of different trade-offs. And well, one person working on an app like this can sort of be very strict in architecture. When you have a big team with a lot of people, you find that the trade-offs become real apparent because everyone does it slightly differently, and different people fall into different traps. And this technology is evolving. So Ecto is very different from ActiveRecord. It's sort of the next generation of ORMs. And they learn from the mistakes from the past. And a lot of these are mistakes that I've seen at scale in big teams with lots of people, with lots of beginners. Unfortunately, I think these technologies are getting better. But it's all trade-offs, and I'll show you what I mean. So as I said, Ecto is an ORM for Phoenix. Phoenix is a web framework for Elixir. Elixir is a programming language made by Jose Velum. It's fast, it's functional, it's got a Ruby kind of syntax. It's highly concurrent because it compiles to Erlang. So Jan talked about Erlang this morning, so I won't get too far into that, but Erlang is a programming language written 30 years ago. It's very fast, it's concurrent. It's made by this man, Joe Armstrong. So he invented it in 1986. They had a problem. They needed to provide, basically, digital phone service to the entire continent of Europe, which is a very, very, very tough problem. They had this telephone switch here, and they wrote 1 million lines of Erlang, and it had 9 nines of availability, which is astonishing. It's got all these amazing properties. It's sort of self-healing. It handles errors very gracefully. And this technology was sort of forgotten about as we moved into the web age, at least from the web developers, because we didn't need this kind of power. The web was too slow because we started with modems, and you couldn't do much with this, so people went into Java and Perl and other things. And this technology kind of languished. But now we have bandwidth, and you can do many things that you couldn't do before. So an Erlang installation has, each server runs thousands, tens of thousands, even hundreds of thousands of concurrent processes, and has a built-in communication system where they can all talk to each other. So it's great for sort of, for instance, real-time systems, but Erlang is sort of like an ugly Ferrari, right? It's fast, but it doesn't have a great syntax. It's kind of cryptic. It's kind of old school, you know? Along comes Jose, and he sort of mixed like Erlang bytecode with Ruby-style syntax, and ta-da, you get Elixir. Now, in practice, Elixir does not have that much in common with Ruby because Ruby is object-oriented and Elixir is functional. So two different paradigms. It's only the syntax, really, that's similar. The similarities kind of only go skin deep. But it's very nice to work with. So now we have sort of like a pretty Ferrari. You know, it's like Joe and Jose cooperated. Now we have something that's fast and beautiful. Okay, so Phoenix is this framework made by Chris McCord. It's sort of like Rails, but for Elixir, and if you've used Rails or any MVC web framework, it will look very, very familiar to you. It's model view controller, it's got a routes file, you've got generators, you've got a package manager, gem in Rails, hex for Phoenix, it's got Mix, which is like this task system for running command line things, and it's got ORMs, ActiveRecord and Ecto. It's very, very, very fast, often an order of magnitude faster than something like Rails. This is DHH. David Heinemeier Hansen, inventor of Rails, he's a race car driver. I wish Rails was that fast. To be fair, it's not really Rails that's slow, it's Ruby that's slow. But what would you do with Erlang or with Elixir, right, in Phoenix? Well, a real-time chat app would be good. And what happens when you do this is the Erlang virtual machine takes care of these inter-server-like communications, and the server talks directly to the server, and it's very, very fast for real-time stuff. Contrast to Action Cable, which is the Ruby on Rails version of this, the servers don't talk to each other. The message transits through a database. So you have a pub sub in Redis. So it's not server to server, it's server to database to server, which is obviously not as fast. So with Elixir, for instance, you could do something like an MMORPG, right? Which obviously speed is everything. And people are really excited about Phoenix because in the past, to do something like this, you had to write in something like Erlang, and it was more like systems programming. And now with Phoenix, these capabilities are coming to web developers. So if you're a Rails developer, right, people are getting really excited about Phoenix because it's a new set of things that you couldn't do the old way with the old web frameworks like Rails. But I'm not talking about that stuff today. Quite frankly, I don't have much experience with it. What I do work a lot with are these ORMs. And this is another place where this technology is changing the way we do development. So this is about trade-offs, and your mileage may vary. This is not a completely objective talk. Some of these trade-offs are very specific to what I found in the projects I've worked with. And this is definitely not a talk that says one is better than the other. It's just about trade-offs and different design decisions. Okay. So and this is my own little. This is my own history of using ORMs. I've used a lot of them. Most of them aren't very good. These are various Java and .NET and Cold Fusion frameworks. But I've used a lot of these over the years, and I'm very excited about the evolution. So ActiveRecord. So I made a little demo app. It's called Hallway Track, right? And the idea was, like, so if you're at a conference, you want to meet people in the hallways who have the same interests as you. You can get on there and you can like schedule a little meeting. But you can see we've got a conference. We've got the name of a meeting. So I want to meet fellow Phoenix fanatics, and we've got a list of names. So this has a very simple database model. It's 3 tables. You've got a conference which has many parties, and a parties which has many users. Okay, so on ActiveRecord, we do something like this. We make these things called scopes. So we've got this class party, which represents a database table called party. We've got for conference, starting after, ending before, and those are where clauses. They represent bits of a SQL query, reusable bits of a SQL query. We set them up like that. And then if we can combine them together in one bigger scope. So here we have a big scope, for conference and time, right, which chains together 3 of those. So you're chaining together 3 where clauses for a SQL statement. So, and then in the controller, right, so you go to the browser, you go to hallwaytrack.com, the route file tells you, oh, this URL goes to the party controller. You call your scope right there using that class method or that static method, and you set this parties variable, and out in the view code, you have something like this. So I'm looping through each party, and then I'm doing party.activeUsers. ActiveUsers is an association. A party has many users, and then I spit out user.name. Well, a funny thing happens when you run this code, which is this. We selected all the conferences, but what happened is we looped through those users is it made a separate select query for each one, which is not ideal. That's not what we wanted, because if you had, say, 100 users instead of just 5, you would end up with 100 SQL queries, which is not ideal. That's called the n+1 query problem. I'm looking at this again. The way it happens is see party.activeUsers. This is happening at runtime, so when we get to that .activeUsers, that data has not been loaded yet, and Rails is not smart enough to figure out that you needed to preload that or to do a join, which is why it fires that off. We don't like that. Also take a look, one thing to notice, user.name, right? This is a method that I wrote on the user model in ActiveRecord, and this is the object-oriented approach, right, where we've got object-oriented is encapsulation, is one of the 3 cornerstones is encapsulation, where we've got data stored in there. We're pulling back data from database, hydrating this object. We have a method on here. We're mixing behaviors and data together, which is sort of what object-oriented programming is, right? So how do we fix that? Okay, how do we fix that n+1 query problem with this .preload? So I added that .preload at the bottom. That tells my ORM, hey, we want to fetch all the user data at the same time we fetch the conference data. Problem solved. But there's another problem here. The preload now, this is my model file. This is the data access layer, but this should be reusable. I should be able to reuse that scope for conference and time everywhere and not have to worry. It should be like universal. And that preload is really specific to the page it's rendered on, because in another time when I use this, I may not be displaying the users, in which case I don't want that preload because that's an extra query. So all of a sudden, I've taken something that should be reusable, and by adding that preload, I've made it specific to this page, which really, because this is the model layer, it shouldn't know anything about. So I couldn't move it. So this is the same controller as before, except that I moved the preload into the controller. Well, that works because this controller is specific to the page and the preload specific to the page. I'm back on track, but I've done something subtle here, which is now I've got basically one query or one set of queries split across multiple files. So it's really hard to keep track of where the SQL is now because actually it's in 3 files. It's in the party model, that scope active users would be in the user file, and the preload is in the controller. So my data access is now in 3 different files, and one of them's not in the model layer at all, it's in the controller layer. So things are starting to get like a little muddy here. And that's one of the problems with ORMs in general. I have fixed the query problem, by the way. I get 2 queries. Even if I have 1,000 users, I only get 2 queries, which is what I wanted. But it's because the reason I got that sort of mismatch is because object relational mappers are kind of a leaky abstraction. So picture like a SQL query is like a dog, right? And you kind of feed it dog food and it barks and you let it outside and you want to treat it like a dog. But Ruby is an object-oriented programming language which behaves like a cat. And you want to like treat it like a cat, you know, and treat it like an object and do object-oriented things with it. But really to use this ORM properly, you have to do both. You have to treat it like a cat, but know it's a dog underneath, and you can't just forget about the dog. Otherwise, you end up with those n+1 queries. So that makes things difficult. It's this impedance mismatch between an object-oriented relational approach and an object-oriented approach, which is sort of hierarchical in nature, nested objects and such, and a database approach, which is relational in nature. It's kind of 2 data models merged into one, which makes it hard to use, and we can't just take those beautiful scopes and forget about our preload or we get ugly queries. So as Joe Armstrong said about object-oriented programming, you wanted this banana, but you got a gorilla holding the banana. So the banana is the data in this case. The database returns data, but that model class has methods on it that operate the data. So you've got data and behaviors together. And that can be good and bad depending on, again, which trade-offs you want. So there's another subtle performance issue here. And the performance issue is that both of those are select star. So all these tables by default have many fields that we're not pulling back. For instance, they all have a field updated at and created at, which do exactly what you think they do. And we're not displaying those, but I'm pulling it back anyway, aren't I? I'm pulling back extra data that I don't need. You find often in big Rails projects, I mentioned all that reusing of those scopes, that they're meant to be reusable. When they're reusable, you don't really know where they're being used. So when you're in the model layer, you don't really know, or you shouldn't have to know, about the view layer they're used in. So people tend to just select star every time because they don't know which fields are going to be used. Or maybe I'm refactoring, and I'm deep in this model code, and I see a scope. I don't really want to change that scope because I don't know how many other places are relying on that. So you tend to just select star all the time just as a safety measure, and at scale, this can really hurt you. I call this seeing stars, right? The indiscriminate use of select star everywhere because of object relational mapper design. You can get around it, of course, but this sort of design just makes it a little bit harder. So Rails, we saw the way you chain those scopes. Really, the benefit of that is this very nice English-like syntax. It ends up being very readable. The chaining looks real nice. It reads like a sentence. You know, party for conference and time. You know, it's objects over data. You know, that's gorillas holding bananas, not just bananas. It's about a domain model versus a relational model. So what I mean by that is like you saw we had our model file that represents a party. Well, really, or a conference, right? Really, that represents a database table, but it also represents sort of like our domain model, like a real life, like a party in real life, like not a computer thing. You know, it's actually our domain, so we're meant to think about it that way and write the behaviors into it, which is to say sort of the opposite of thinking about it purely as a database table. And I say Rails favors productivity over scalability simply because I think like those errors I showed you, select star indiscriminately, those n+1 queries, it makes it easy to make those mistakes, but the upside is you can develop really fast. You can knock out Rails applications very quickly, and I say it favors developers over DevOps because those, like I said, those queries get spread out over multiple files. Oftentimes, you know, our DBAs, our DevOps people, they look at, hey, this query is really slow. Where is this query? I don't know, boss. It's spread out over 6 files. You know, let me see if I can find it. So we don't know if SQL and Rails are really friends or frenemies. It kind of ends up being both. So we're Java champion forcefully protecting programmers from themselves. Ruby included a hanging rope in the welcome kit. That's true of Rails too. It makes it really easy to make SQL queries with poor performance. So, but on the upside, readable English like DSLs, it's conceptually simple. You've got a user model. What could be simpler? It's comfortable for beginners. And I like to say it favors convenience and rapid development, right, over explicitness and performance. And explicitness is a word I'm going to use a lot. That's sort of our word of the day here. Now that we're going to get into Ecto, you're going to hear me use this word a lot. So Ecto. So the world is changing. We're left object-oriented land. We're to functional programming. Obviously, this architecture is going to look different. We're going to have not better, not worse, but a different set of trade-offs. So where in Rails we had something simple, we have users in real life, that's our domain model, we have a user's model, which maps to a user's table. Ecto, we have these 4 things, a repo, a schema, a change set, and a query. Those are obviously computer terms, right? So we're out of domain land into computer language land. So first of all, here's my model. Here's my model for party. And first of all, I'm just defining a schema. I'm defining the fields so that my application knows what fields to expect from the database. You don't have to do that in Rails. So this is a little more boilerplate. But I set up my relationships, has many users, belongs to conferences. In the controller, I'm going to have something like this. So to set the parties variable, I've got repo.all. Okay, so now we have another difference. Whereas before, for instance, my party object, it was just an object called party, and it was responsible for fetching its own data using its class methods or its static methods. Here we have to pass that sort of query representation to a repository. This is the repository pattern, which is a little more boilerplate, a little more code to write. It doesn't quite read like English like the Rails version did, but it is more explicit, and also we have to explicitly define which HTML template it's loading. So a little more wordy, a little more verbose here. If you're into formal definitions and you're like Martin Fowler in his books, this is the repository pattern. Whereas ActiveRecord, ActiveRecord, the ORM, is actually a lot more than just the ActiveRecord pattern. It's kind of like 18 different patterns all rolled into one. But that's the formal definition if you want. I mentioned that ActiveRecord, the Ruby on Rails version, returns objects. Elixir, Phoenix, cannot do that because there are no objects. This is a functional programming language. So what it's returning is structs. And structs are dumb data structures. They don't have behaviors attached. It's a banana, not a gorilla holding a banana. There are no methods because there are no classes, there are no objects. Embarrassingly, that means technically Ecto is not an object-relational mapper because there are no objects, which means the whole title of my talk is just a little bit flawed. I apologize for that. But then when we actually go to put the query part, we have this in our model. So from party, where party equals select. This looks a lot like SQL, doesn't it? That's actually kind of nice if you like SQL. We didn't split our queries out over 18 different files, right? We also don't get that nice English-like syntax. But if you like SQL and you like explicit and you know what's going on at database level, what could possibly be clearer? Also notice the select. When we write SQL, we always write a select, right? So it's natural to come in here and always put a select clause in your Ecto query. You don't have to, but if you remember to, we no longer have the seeing stars problem, right? It's a gentle nudge. It doesn't solve the seeing stars problem where everything is indiscriminately select star, but it gently nudges us in the right direction by using this kind of syntax that encourages us not to forget that part, which is at scale really, really matters. For instance, at Procore, we have 18 web servers, but we only have one database server. It has, I think, 128 cores and probably costs as much as a Ferrari, and we have to keep buying bigger and bigger and bigger ones because of problems, because it's the bottleneck. So at scale, that really, really matters that you're not doing select star everywhere. So here's another little example if we want to preload the data. So now it's going to do 2 queries. It's going to pull parties. It's going to pull the users that match. But the feature here is that preload is not in the controller. It is in the model. This is no longer really reusable because that preload is specific to the view I'm rendering. But that's just a different set of trade-offs here, right? It's less reusable, but it's more explicit. There's that word, explicit, right? When you start doing group bys and stuff, the syntax gets really nice. So here I'm grouped by a topic ID. Notice the select at the bottom. I'm selecting party.id and the count. That's real natural looking, real SQL-like. Not English-like, like Ruby. It's real SQL-like. Does anyone know where the syntax came from or where they kind of got this idea of doing this, by the way? It came from Link, from Microsoft. Yeah, Bill. Nice dance moves. This is an example, a rare example of the open source world taking something from Microsoft land instead of the other way around. Okay. And so here's what my file looks like, and this is where my personal preferences sort of leak into this talk. I don't like to reuse parts. You can reuse parts of queries. In general, you can use ActiveRecord in the way that is generally in sort of the Ecto style, and you can use sort of Ecto in the ActiveRecord style. Where it really starts to matter is when you've got 30 people all doing different things, right? Then what becomes more important than what you can do is what it sort of nudges you towards, right? Then all of a sudden, sort of the trade-offs become more apparent because everyone does things differently, and you find people following into the same pitfall. So notice that all of these have the same where clause. I like to just reuse it and make it look like SQL and copy-paste that rather than like chaining things together and try to reuse it. More boilerplate, less, but more explicit. Okay, so when we move to writing then, Ecto has this great feature, right, called change sets. Here's my schema for user, right? It has name, email, and it has age. I define that, which is more boilerplate, but it allows us to get nicer things, nicer error messages and things like that. And in there, we do this thing called a change set. So we take that user struct and we use that sort of pipe operator. So to pipe it through like a casting part and then validator, so validate that email. So then we do another validation there for the age that is included in that range. And then we let Ecto know that there's a unique constraint on that, and that's mainly so it can generate nice error messages if it gets a unique index error. So I set that up, and it's kind of funny. I have to set one of these up for every different write operation that I do. So I've got that. That's for creating a new user, right? But if I also want to give them the ability to update the email, I have to make another change set. So the top one would be for like a registration page. The bottom would be for like an update account page. And I've got two separate change sets. More boilerplate, more code to write, but it's more explicit, right? And what's nice about this is that like I have different sets of validations for each one. In Rails world, you kind of define the definitions in the validations, right? The validations are in the model file, and that means the assumption is that all of the different writes in Rails are going to use the same validations. In practice, that ends up not being the case. You end up with different validations on different pages, and so you end up having to tack conditionals onto your validation. Validate unique if, you know, something this and this and this. Whereas Ecto just assumes right away that you're going to have different validations per write operation and makes you explicitly define each one. More boilerplate, less convenience, more explicit. So it's also got this great thing called a multi. If one page, one forum post wants to make 3 write operations, I want to insert into topic, insert into party, update conference. You wrap this in this sort of multi, and then you run it, and it runs it in a transaction, and you pattern match against the output, whether it's OK or error. And that's a really nice construct, and it encourages you to remember transactions. One of the things I notice, especially with beginning programmers, is in Ruby, is that they often forget the transaction block. Especially, you see a lot of them, it's, user.save, topic.save. Well, guess what? You didn't wrap in a transaction. Whereas in this, if, it gently nudges you, gently encourages you to use this on every forum post, in which case you never forget your transaction. So it doesn't solve that problem. It just, makes it easier to remember to do the right thing. So separate sets of validations, more explicit, better security. You end up in Ecto doing a lot less like forming little bits of SQL out of strings, which means less vectors for SQL injection. Contrast that to the Rails approach, which is this. Rails makes it really easy to update. So I find my user record, I set the email, and I save it back. There's your gorilla holding a banana because you've got your save behavior tied right into the object that holds the data. That's good. There is more potential for abuse here, though, because what I find in big apps with multi-levels of architecture and classes is people start to pass those objects around and hit .save at different levels. If you're disciplined, you may not do that, but a lot of people naively do that by accident, especially on big apps, especially with inexperienced developers. So it's convenience, but with more ways where you can write inefficient code and end up doing extra saves, and your saves can end up scattered across different layers. Ecto makes that just a little bit harder. You can do it, of course. You can make all the same errors, but it gently nudges you into ways that encourage you not to abuse these features. So as Jose says, functional programming is about making the complex parts of your program explicit. And in most web apps, in most CRUD-style web apps, the complex part is taking that data, which is stored in a relational way, and sort of transforming it, querying it, rearranging it, and getting it on the page, which is essentially a hierarchical way. In my little web page, for example, I had conferences, each of which hierarchically had a party, each of which had child of users. That's a hierarchical representation versus what your database stores is a relational one. That is the complexity in most web apps. So it's about making that more explicit. So, and interesting, if you're once again into definitions and patterns, Martin Fowler defined this command query, responsibility, segregation. That's a mouthful. But what it means is that reads and writes use sort of different paradigms, different ways to model the data. So in Rails, for instance, the user, it's that same file, it's that same model, it's that same class does the reading and the writing, the selecting and the saving. Well, if you think about the way a database works, that's not actually what happens. So, because when you read, and anything non-trivial, when you read, you're usually doing like a bunch of joins, aren't you? But when you write, you don't join. When you write, you only write to one table at a time, the whole row. So reads and writes use fundamentally different structures. In Rails, they sort of convert that into this, they use a single class, a single object to represent both those operations, even though they're very different. In Ecto, reads and writes are fundamentally different. They don't use the same methods. There are no classes, of course, so they can't be encapsulated in the same class, but they're treated as separate operations with a different way of representing that in your code. So just to summarize a little, Rails is about objects, Phoenix is about data. Rails has methods, Phoenix is about functions. Rails returns mutable objects, objects where you can query it, get back the object, change the data, save it back again. Phoenix returns immutable objects that cannot be changed. Rails favors English, whereas Phoenix ends up looking more like SQL. Rails, it's very easy to always select star, where Ecto just gently nudges you to think about it. Rails is lazy loaded, Phoenix is eager. Dispersed and confined, what I mean by that is I feel like, just in practice, Ecto encourages you to kind of have all the query stuff in the model layer and not get it so spread out. And the downside, more boilerplate, more complex mental model. Instead of just a user model, we've got these change sets and these schemas and all these other things. It's less dry, there's more copy-paste. Is it less readable? That depends on what you're used to. If you like your code to read like English, then Ruby's probably for you. I find Phoenix looks a little bit more like SQL, but I like SQL. I love it. It's more like computer talky, I always find myself talking in SQL. My wife's like, hey, Brad, will you do the dishes? I'm like, select dishes from sink, insert into dishwasher. She's like, Brad, what are you talking about? I'm like, oh, sorry, sweetie, I was talking SQL. So I don't mind it. I say Phoenix, it favors sort of explicitness and performance, right? But at the cost of some convenience. You can't quite rapidly develop quite as fast as you can in Rails, but it's more explicit. It's easier to know exactly what's going on at the database layer, and which allows you, which sort of leads you to make fewer performance-related mistakes, like n+1 query or indiscriminately always selecting star. Ecto lets the database do what it's good at. It adds foreign key constraints by default, for instance. ActiveRecord kind of encourages you to do everything in the app. It actually enforces unique constraints and foreign key constraints if you want at the app level, which is not safe to raise conditions, it turns out, although that may be a feature because it's less locking. The testing story ends up being very different too. Ecto's functional, you end up with pure functions. You don't have that gorilla holding a banana, so there's less stubbing and mocking, I find. And it's also kind of cool because when you fire off the test suite, it's concurrent, it's Erlang, so it fires off 50 tests at the same time. It's cool, it's not just for SQL. People have made adapters for Ecto, so you can query, for instance, the GitHub API, which is really cool, so you can make it a REST adapter. It's not just for database. And just to sort of sum this up, realize, like I said, this is a tale of trade-offs, and a lot of this was influenced by my own experiences. Your mileage may differ. Not every design is perfect, or there's no design that's best for every project universally, so you have a choice in object-relational mappers. Pick the one that's right for you, and also you have a choice in the way you use them. Use it in the way that you think will encourage the best architecture for your application. A few resources here. I'll post these slides on Twitter so you can check those out. My name is Brad Urani. Follow me on Twitter. I love tweets. Connect with me on LinkedIn if you like. I've got a blog, but I don't update it very much. I work in Santa Barbara at Procore. We are hiring. We do Phoenix, Rails, JavaScript, React, all this awesome stuff. If you want to move to California, come find me. It's gorgeous. I promise. That's the view from my office. Thank you very much.
Thanks for the talk.
Yeah.
What you've shown us is actually two different approaches, right?
Yeah.
Because I'm not a Rails person or a Ruby person for that matter.
Yeah.
I'm more a Python person, and there is this nice library, SQL Alchemy, which has actually both of these approaches built in. There's the core module and the ORM module. So this talk is not really about two different frameworks of things. It's two different approaches, right?
Yeah, that is true. This is definitely colored by my own experience, and the code I showed you in Ecto is how I like to use Ecto. I think what's interesting about it is the Phoenix community is still very young, whereas if you look at big Phoenix apps, even by well-regarded developers, people use it in slightly different ways, and I don't think it's settled out. In the same way, the Rails kind of best practices and conventions are a little more settled because it's older, it's an older framework and whatnot. So yeah, you can use Ecto and start to really chain things together and really try to make every bit of your query reusable, kind of like you do with scopes in ActiveRecord. So maybe that's my own preference to sort of make it look more like SQL and copy paste. I think that I like Ecto because I like that style and it makes that a lot easier. Whereas trying to do that kind of thing to make it look like SQL and not reuse things so much and avoid some of the problems with reusing bits of queries all over the place is harder to do in ActiveRecord. It's much easier to use ActiveRecord the way it was intended to be used, which is to chain all those scopes together. Anyone else?
Hi. Yeah. Great talk, thanks. I would like to ask, do you see this as an advantage that Phoenix and Ecto actually are totally separate projects? In the terms of working in such a big teams, because you can, for example, have microservice, which is responsible only for the database layer, and the Phoenix is like the separate application in different repo, and they are just communicating with each other.
Yeah, I guess it's good. I mean, but you can do the same thing in Ruby. You can use ActiveRecord in your Sinatra project, or you can take it out and swap it in with a different ORM very, very simply with just a few changes to like the gem file and stuff. So yeah, I think it is better. I generally favor lots of smaller packages that you can use and mismatch, but really Ruby's the same way, I think. The Rails community is the same. It's just as easy to change, I think.
Great, thanks.
Yeah.
An excellent talk. I'm wondering about your Ecto queries, this from syntax. Is it a macro? And this caret, is this like quoting, unquoting? And following up, is the rest of Ecto also macro heavy?
Yes. So,
Exactly.
Yeah, so right here, yes, it is a macro. From is a macro that gets expanded. And that little caret in front of conference ID, that is to actually, to get the, I don't even know what you call that, to get the value, right, instead of the reference when the macro expands. Yes.
And is it like a typical approach to have those macros all over the project?
I guess so. A lot of Rails has like hundreds of thousands of gems and years of development, and so people have sort of like started. You find a lot of people use the same ones. Phoenix being much younger, a lot of the really essential packages haven't been developed yet. So I think it'll be interesting to see how heavy they are on macros. I'm guessing people are going to get pretty fancy with it, and you'll end up a lot. But that's a good thing. It's a powerful feature. Yeah.
Thank you very much for all your questions, and thank Brad for his presentation.
Okay.